Now you can see the screen, and the screen is one node. Am I right?
Yes, sir.
Okay, thank you, Tyler. Okay, so now we are going to sketch. Okay, we are going to sketch the distribution now. Okay, so I'm going to draw the cross section. Hey, come on, Eugene. Okay, so this is our cross section, and our to sketch our transformation y z rotation in x. Okay, so by observation, we will know that this is a centroid. Okay, this is by observation. So this is our centroid geometry. Okay, it's a geometry feature. So the next thing that we're going to do is we're going to sketch stress x. So this is normal stress in the x direction. This is a y, and I'm going to draw a line. Okay, and at this point is where is px over a. Okay, a being the cross sectional area. Okay, so this is how the stress is distributed. So this is due to the axial load. Okay, and then I'm going to sketch the next one. So the next sketch I'm going to do okay. So again, this stress in the x, and this is y, and we are aware at the bottom is in compression and tensile, right? So this is how the stress will distribute. So at the bottom is under compression, and the top is under tension. Okay. So this curve that you see down here, it is your minus mz over izz multiplied by y. So over here is compression, is pushing towards the y-axis. On top is pulling away. Okay. So relative to y, I'll elaborate again that this position is the position of our centroid. Okay. So this is where our centroid is. Okay. Now, if we were to add these two graphs together, and we're going to have an outcome. So this is equal to what? Okay. So now when we add those two together, right, it's what we call superpositioning, right? So this is our stress in the x direction, y. So when you combine the two, I'm just going to copy this. The gradient will be the same. The only thing difference is there'll be a shift. Okay. So hold on, let me. Okay, there will be a shift. Okay, and this is how the shift will look like. So what you see over here is this part is still going under compression, right? And then above it is going to go through tension. Right? So this position over here is still our position of the centroid. However, if we were to look at the neutral axis now, the neutral axis has been shifted. So now this is the position of the neutral axis, where stress X is equal to what? 0. Okay. So you can see when our structure is under, okay, you can see now where the structure is under eccentric, symmetrical, bending. Okay. The position of, or the positions of the centroid and neutral axis, okay, and the neutral axis are not the same. Okay, so that's where we have to distinguish the two differences. Okay, we have to distinguish the two differences. Okay, right. So now what have we? What is important that you have learned so far? Okay, let me very briefly summarize what we've learned so far. Is I taught you a simple way to analyze a structure to look at when it's compression or tension. The head of the moment vector is always compression. The tail end is always tensile. Okay, and then we have defined what we mean by centroid. Right, centroid is a geometrical feature. Neutral axis is a stress field feature. Okay, and the rest, yeah, like all these formulas over here, you have minus over here. All I can say is don't worry about it. Okay, I'm going to teach you how to visualize it. The other thing that we have learned is we also have learned where to locate failure. So at this point, failure is at the joint, and then over here, failure is at point C. Now, why is failure at point C? Okay, why is failure at point C? Okay, we have to be really careful down here. Okay, when it's simply supported, right? When it's simply supported, failure is at point C, right? When it is a cantilever beam, failure is at point A. Because point A, we don't allow motion. But then why, okay, when it is a cantilever, it is simply supported, right? Point A and point B, we don't allow motion. Why then failure occur at point C? Okay, so I think a better term to explain this is let's discover where maximum bending will occur. I repeat again, where maximum bending will occur. It's more important than restriction. Okay, sometimes the restriction that which I taught you guys regarding jumping from the fifth floor where we were there, sometimes it works, sometimes it does not work. So that's where you have to be careful. Okay, more important, okay, is where maximum bending will occur. Okay, So we are going to, I'm going to, we are going to go to failure will always occur where bending moment magnitude is the highest. Okay, where bending moment magnitude is the highest. Okay, so I'm going to now. Okay, we're going to go through this by review the shear force and bending moment equations and diagrams. Okay, as I said, you have been taught 2P before on this aspect, but 2P, some of you have taken at least more than a year ago now. You return everything to Dr. Koshi, okay, or you have forgotten everything because it's online. Learning online is very different to learning face to face. Can you tell me the difference with learning online and face to face? Anyone? Can you see any difference, or you have not learned face to face before? Anyone? Let's sidetrack a bit. Easier to get distracted. Easier to ask a question in person. Matthew, don't know. No. You're right. Easier to ask question. Much easier to fall behind. Yeah, absolutely right down here. The difference is this. If you were to just watch my recorded material, okay, by watching the recorded material, easier to leave class and fall asleep. When you watch my videos that have been posted, right, does not mean watching it means understanding the topic. Okay, I'll give you an example. I cook curry. Okay, one time my curry went bitter, and I don't know why. So so what we tend to do is we YouTube, okay, and you just YouTube bitter curry, okay, how to unbitternise your curry. The solution is to put salt, not to put sugar, to put salt, okay, and then the bitter taste will somehow diffuse itself. And why my curry became bitter? I was greedy. I put too much curry powder. Period. Okay. Now the next time, if I were to cook another dish when it's bitter, is the solution to put salt? The answer is no. Because the solution that I got from YouTube by putting salt when your curry is bitter is a very unique solution, and I don't know why. I just follow. Okay. That is the problem when you learn from just online, not like now. When you talk to me, I will stop and I'll elaborate. Okay, two different things. That is why it's important to have synchronized classes. And if, as I say, if the term gets later on and you have more problems understanding it, I will show up in person. If you find learning that way is better, I will do it. Okay, that's why we have to be careful when we learn online. Okay, just a bit of distraction over there. Okay, so now we are going to review your shear force and bending moment diagrams. Now, doing this review, okay, I'm going to show you what I'm going to show you is this. Okay, so we have drawn a cantilever beam before, right? We have drawn a cantilever beam before.